Hi everyone, welcome to a new video in the hydrocarbons chapter. This one we're going to look at alkanes. So remember that hydrocarbons were molecules that just contain carbon and hydrogen. Alkanes are a smaller part of that. So alkanes are hydrocarbons, but they have some extra criteria to fit that. So here we go in bold. Alkanes are saturated hydrocarbons. Now remember the definition of that they only contain carbon-to-carbon single bonds. So as we can see here on the left in our diagram, carbon, carbon, carbon. The carbons are actually in pink this time. Usually they're black and the hydrogens are white. But anyway, let's roll with it. There's only single bonds between all these carbons, not double bonds. So here for propane, it's just a chain of 3 carbons with a single bond in between them. So 2 single bonds there. And here with butane, it's just a chain of 4 carbons with a single bond in between them. Okay, so those two are alkanes, and we'll talk more about the naming, how you can tell from the name as well. So alkanes can consist of a single chain, like we see in the diagram here, or they can be branched. You can also get, say this one, carbon-carbon coming off from here, but to be an alkane, this branch also can only consist of single carbon-carbon chains. They also have this property of having their molecular formula have this general rule of Cn, when there's n number of carbons, there's going to be 2n plus 2 hydrogens around it. And thinking about that, I might draw it on the model here as to why. Let me just erase my scribble. So, for every carbon, there's at least 2 hydrogens attached to it, even in the middle there. Okay? But at the ends, the carbons in an alkane have this extra hydrogen. So each carbon along the chain, I don't know if my diagram's helping here, each carbon along the chain is going to have at least 2 hydrogens on it. But the 2 end ones are also going to be there. So for n number of these, there's going to be 2 NHs, and there's going to be an extra 2 on the end. So that's why it's CnH2n plus 2. So you're going to get, if it's carbon 1, okay, H2 times 1 plus 2 is 4. So CH4, which is our methane. If C equals 2, C2, H is going to be 2 times 2 is 4, plus 2 is 6, C2H6. And if it's C3, we're going to get H, 3 times 2 is 6, plus 2 is 8, C3H8. And that's what we see here in propane. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. And C4, 2 times 4 is 8, plus 2 is 10. So H10, let's just check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So they fit this CnH2n plus 2 rule. So if you've just given a formula for a molecule, and you see that it just has carbon and hydrogens in it, it's a hydrocarbon. And if you see it fits the number of carbons and the number of hydrogen fits the n to 2n plus 2 rule, you know it's an alkane. Okay, what's the use of alkanes? What do we do with alkanes? Where do we get them from too? So we get alkanes from oil deposits in the Earth's surface. So the origins of this is many years ago, millions and millions and tens of millions of years ago, algal life and stuff like that. When it died, it was deposited, say on the bottom of the ocean or the bottom of a lake or something like that. And it was then, excuse me, soil or mud put on top. It was compacted, and over time, that life has has kind of broken down and there's been a chemical reaction, and it turns into oil over millions of years. Bit more extra info, follow that YouTube link, it's a good video. So we extract the crude oil and we dig it out, and part of that mixture of the oil, the crude oil, is a very, very, it's a mixture and it's got a lot of different compounds in there, but alkanes are part of that. Methane, what we use methane for, which is the smallest alkane, is used for fuel. So we do a combustion reaction and it leaves energy left over that we can use to do stuff like cooking or turning turbines and stuff like that. So what we call natural gas in the home is actually just methane, and they put a couple of other things in it to smell, but it's mainly just methane. So the public, or what I call muggles, call it natural gas. Propane we also use for a fuel. That's usually LPG. And it's usually a fuel where the natural gas, so we don't have natural gas piping, is not available. It's safer to transport in tanks and stuff like that. So usually where there's not a natural gas grid, people will be using LPG. We also use it for barbecues, for camping and stuff like that. It's a lot safer to transport because it's actually is a liquid. We compress it so much it turns into a liquid. Petroleum, so what we call petroleum, or what the US call gas, it's a mixture of hydrocarbons and other stuff. So 30% of these are alkanes, and there's a mixture of pentane, which we'll soon learn is 5 carbons long, to octane, which is 8 carbons long. So it's a mixture there. And so when you combust hydrocarbons, what ends up happening is they combine with oxygen to produce carbon monoxide and water to various stoichiometric ratios. I didn't bother balancing that general equation there. So combusting hydrocarbons gives carbon dioxide and water, and that's what we do in cars and stuff like that, and methane in natural gas. So we're getting carbon dioxide and water, and we're getting energy left over to do stuff. So these long chain molecules have a lot of bonds in that we're breaking, and there's not as many bonds in here, so there's energy left over. It's an exothermic reaction, highly spontaneous. It's an exothermic reaction, and we use that energy to do stuff for us, like to cook stuff and heat stuff and make mechanical parts move. Okay, so let's talk about naming alkanes, and here we've got a syllabus point. Here I finally put it in. Investigate the nomenclature, hard word to say, but just means the naming rules of organic chemicals up to C8. So that's talking, say, up to 8 carbons long. Using the IUPAC conventions, these are what I call the chemistry wizards. So the Council of Chemists, Applied Chemistry in Europe, no, probably international now, they get together and they decide on naming rules and stuff like that. So we're looking at their naming conventions, including simple methyl and ethyl branch chains, which I'll talk about more. So we need to talk about the naming of alkanes, alkenes, and alkynes. We need to define them and talk about the rules in naming them, and also the halogenated compounds we'll get to soon. But I'll just cover alkanes in this video. So naming alkanes, all of them will end or have the suffix. Suffix is just the fancy word for the end of the name, with ane. They'll all end in ane. So when you see the word ending in ane, it tells the reader that it's a saturated hydrocarbon or it's an alkane. For example, when we hear the word hexane, don't worry about the hex yet, we'll talk about that very soon, but the ane on the end tells me, hey, we've got an alkane, we've got a saturated hydrocarbon. Also with propane and decane. Okay, before the suffix, the prefix part of the word is stating the number of carbons in the chain. Okay, and these using, I think they're Greek, aren't they? but these prefixes here in this table on the right. So, methane is saying that, number one, it's an alkane, it's saturated hydrocarbon. Number two, meth tells us that there's only one carbon there. So, methane, one carbon, four hydrogens. It's an alkane with one carbon. Ethane is an alkane with two carbons. Propane, an alkane with three. Butane, an alkane with four carbons in a chain. Pentane, five carbons in a chain. Hexane, six. Heptane, octane, nonane, decane, undecane, dodecane. Now remember, in the syllabus they're only asking us to learn up to 8, but I mean, we know the prefixes non and dec from shapes from primary school, so we should be right to handle those. If you want to push yourself into undec and dodec, go for it, but most likely not going to be asked about those. Okay, so with this straight chain, not all hydrocarbons will consist of a single carbon chain. Many will have branches, okay? So we're starting the basic. We're giving you simple ones. And here I've given you a diagram of pentane. 1, 2, 3, 4, 5 carbons long in a straight chain. So just nice, simple pentane. Okay, I've kind of done this one on there. So notice methane, ethane, propane. I put them in order of the number of carbons here. And I've also given the formula for it. And you'll notice they fit the 2n plus 2 rule. For example, why not take nonane? C9H20. Now, does that fit the 2n plus 2 rule? Well, 2 times 9 is 18, plus 2 is 20. Yes, if you just see C9H20, you know that it's an alkane. And you know it has 9 carbons in there. Now, you don't know if it's nonane, but we'll get to that soon. Okay. So they fit this 2n plus 2 rule. Straight chains will have the general expanded formula. So if we want to use the, expanded, it's slightly condensed, isn't it? That's wrong. So at the ends, they'll have CH3s, but in between, there'll be a number of CH2s, okay? So methane's the one exception because it's got its CH3 on the one end, but it can only have that. But you can see that ethane consists of 2 N blocks of CH3. And propane is the first one. It's got its CH3s at the end and a CH2 in the middle. And butane has its 2 CH3s at the end and 2 units of CH2 in the middle. So that's another way to draw a condensed formula for your alkanes. Now, there's something also called cycloalkanes, and remember we talked about cyclic compounds before. These are just alkanes that have they're saturated hydrocarbons, but their carbon chain, instead of being straight, loops back on itself. So we call this a ring or a cycle. So these do not fit the CnH2n plus 2 rule, okay? Because they don't have those N carbons. If they have one loop, they follow the CN2N rule, and 2 loops, we lose 2 extra hydrogens and stuff like that. But it's very unusual that they're going to give you any of those. But they fit the CnH2N rule, and they're still an alkane because it's carbon-to-carbon single bond, but you lose those CH3s on the end. You can't have a CH3 on the end because there's no end to the chain. So it's just a series of linked CH2s in a circle. So what we do to name these is we just use the prefix cyclo before the name, okay? So cyclo first, and then the other prefix for the number, and then the ane at the end. For example, it's a bit blurry. I should do a better diagram. Cyclopropane has 3 carbons in a chain. Cyclo tells you it's in a cycle. Prop tells you that there's 3, and ane tells you that it's a saturated hydrocarbon. We've also got cyclobutane, cyclopentane, cyclohexane, cycloheptane. It would also go up to cyclooctane. So they have the general rule of CnH2n, or you could just write CH2n, not really represented by that, and not really very often like that too. And And there's skeletal structures down here too. Just those carbon-carbon bonds. Alright, so cycloalkanes. So naming alkanes, we follow several steps. First, we want to determine whether it is an alkane. The name will generally end with ane. It's a good indicator. Determine the longest carbon chain. And remember, this might not be drawn in a straight line. It might be branched. Okay, the body with the body of the name will then be based on the number of these carbons. For example, if your longest chain in there is 6, it will be a hexane. Okay, after that you need to find branches. Branches and other things we call substituents. Things that aren't just hydrogens on that backbone, we call substituents. And when they're a branch of carbons, we call them alkyl groups. Like they're alkane branches, alkyl groups. The YL usually tells you that you've got a branch. Ul in this naming means branch. So when you see a YL in the middle of the name, it means branch. For example, the branch that is 2 carbons long is called ethyl. Okay? If you see ethyl octane, you know that you've got octane, 8 carbons long, with a branch on there. Ethyl means 2 branch. So you've got a branch of 2 carbons off this octane. So you number the carbons in the main chain. You actually number them 1, 2, 3, 4, blah, blah, blah. And you can start at either end, but there's a correct way to do this. And this is where the things, like the branches on there, will have the lowest number. Okay, and I'll show you some examples of that soon. If there's more of one of these branches or other things attached, they are listed at the start of the name in alphabetical order. That is, an ethyl group will be before a methyl group. So a methyl group has got 1 carbon long. Ethyl will be named before methyl in the name because E comes before M. And both will be before a pentyl group because P comes after E and M alphabetically. If there are more than one type of the substituents, we start to use the naming style. So if there's 2 methyl groups on there, we use dimethyl on there. Di, tri, tetra, stuff like that. Okay, let's do some examples. Okay, do I want a different colour? I might go for blue. Okay, so name the picture alkane. Okay, we've got a carbon-to-carbon backbone here. And that's it. It's a nice simple one. It's just got this, we call it a straight chain hydrocarbon, even though it's bent. Remember, 109.5 degrees in 3 dimensions here. But we call it a straight chain because it doesn't have branches. So this is a nice simple one. We need to count how many carbons are in here. 1, 2, 3, 4, 5, 6. Now we haven't got anything else on there. So it's 6 carbons long and nothing else. Now it's an ane. We've got single bonds. So what I might do is start writing it out. It's an ane. Now the main chain on there has 6 carbons long. So it's a hexane. And there's nothing else. So what we've got here is just hexane. Nice simple one to start off with. Okay, let's make it a little bit more difficult. Naming this one. Okay, have we got an alkane? Well, these carbons are all single bonds. Oh, we've got a branch there too. So we still have an alkane. So I'm going to start at the end of the name and start writing in ane. Okay, identify the longest chain. Well, 1, 2, 3. No, 1, 2, 3, 4. Oh, hang on, you can't see this. Okay, you can go 1, 2, 3. Well, you can see there's a longer chain elsewhere. Let's go back. 1, 2, 3, 4, 5. That's another option. That's longer. That's good. I've got another option here. 1, 2, 3, 4, 5. Okay. So our longest chain is 5, no matter which one we're going from. And both are identical around these branches. So it doesn't really matter. The molecule is the same no matter if you start 1 here or 1 here. Doesn't really matter, okay? So let's just choose one way and clean this up a bit. Okay, what I'm going to do is, I deleted my ane at the end. Okay. What I'm going to do is, to make it simple, just name this 1, 2, 3, 4, 5. Okay, the other option is I can name it 1, 2, 3, 4, 5. Okay, so I've definitely got a pentane because it's 5 long. Pentane. Now, it has got, I've designated this as a branch, and it's 1 carbon long, so it's a methyl branch. So we've got a methyl pentane. Let's see if my texter could write. My pen. Maybe to write now. Oh, technical issues with my pen. Oh, there we go. Okay, it just doesn't want to write there. There we go. We have a methyl pentane. Now, I know I'm working backwards, but I'm trying not to leave a space in here. These words all blend together. We've got a methyl pentane. Now, we have to consider that the position of this branch means a lot, because it could actually be methyl pentane here as well, here as well, and we can't really be it at the ends, because if you put a methyl branch on the end, it just extends that longest chain. Okay, the rule is where you've got a substituent or a branch on there that you want the lowest number. So if I start with 1 up this end, 1, 2, 3, the branch is on the 4. But if I start the 1 up this end, the branch is on the 2. The correct way is that it must have the lowest number. So this must be carbon 1, this must be carbon 2, 3, 4, 5. That's the correct way to do it. So the methyl branch is on the 2, so 2 methyl pentane. Okay. I need to put the 2 there to show where that methyl branch is, because there could also be another methyl pentane that's on the 3rd position, and we'll go more into what these things are. These things are called isomers. I've mentioned them before, but we need to put, in this instance, the 2 there because there is another methyl pentane. Okay, let's do example 3. Let's look for, have we got an alkane? Oh yes, carbon to carbon. It's a single bond. So I'm going to write the end of the word as a name. Identifying the longest chain. 1, 2, 3, 4. I feel that's 1, 2, 3, 4, 5. Okay, so it's 5 carbons long, and there is this methyl branch on there. Alright. So I could also name it, remember, 1, 2, 3, 4, 5. Okay. Putting in the name though, I definitely know it's pentane. I'll put that 10 before that. And it's got a methyl branch on there, nothing else. So it's a methyl pentane. I'll write that on there. Okay. This branch here, we could number this carbon 1 or this carbon 1, but wherever the branch is, whichever way we start, it's always going to be on the 3. So it doesn't matter which carbon we call number 1, because it's symmetrical in this molecule. So which way you start, it's always going to be on the 3. So we've got a 3-methyl pentane. No gaps in the word. Letter 3, number 3, dash, methyl pentane. No spaces in between the 3 and the dash in the end. Look at what I did here previously. So I just moved this methyl branch onto the 3 position. So that was 2 methyl pentane, and now we've got 3 methyl pentane. I've just moved the methyl branch over, and we needed to put those numbers in there because 2 methyl pentane and 3 methyl pentane are different molecules, but they're both methyl pentanes. We just need to say where the methyl branch is. Okay, example number 4. Have we still got an alkane? Single bonds between all the carbons, so we're still, oh, and this one here, don't forget it. So we've still got an ane. Okay. Oh, I need to use the eraser, don't I? Terrible, I can't just use the backwards one. There we go. Okay, so we've got an ane. Back to the pen. Okay, what's our longest chain here? 1, 2, 3, 4, 5. I've also got 1, 2, 3, 4, and then 5 up here. So I've got this methyl branch right at the end, so it doesn't really matter because it's symmetrical about here, whether this one's the 5 or this one. I can just call it. But if I start to number 1, 2, 3, 4, I'm only getting four carbon chains, so that's not right. So this part is going to be a branch. Okay, so let's erase that. Okay, oh, dot. Let's go back. So I've decided that 1, 2, 3, 4, 5. So I've still got a pentane. Oh, I've got a little bit of a space there. Sorry to be pedantic, but these rules are specific. Okay, I've got a pentane, and I've got this branch here, and I've got this branch here. Okay, there's also another way to number this backbone with a 1 up this end. 2, 3, 4, 5. So I've got 2 methyls, so it's a dimethyl pentane. Dimethyl. Enough room there. So di meaning 2 methyl branches on the pentane. I need to say where these methyls are number-wise, because there's probably a few ways that I can have a dimethyl pentane. Okay, starting with 1 up this end, I've got a branch on 3 and 4. Starting with 1 up this end, I've got a branch on a 2 and a 3. A 2 and a 3 is lower than a 3 and a 4, so I've got a 2, 3 dash dimethyl pentane. So I started with my number 1 up here because it gives me the lowest numbers for the methyl branching. Alright, this next example, oh, I'm zooming in. I don't want that. There we go. Okay. Have I got an alkane? Well, yep, single. So I've got an alkane. Ane. Rub out my scribbles. Okay. Alright, I can see, might be getting a bit more practice, that I've got the longest chain all along here, but you'll notice I get to here and I could go this way, or this way, and it's symmetrical. I can get the longest chain. So just choose one, it doesn't matter. It's all symmetrical out there. I'll make it easier and just have it as straight as possible and call these branches. So how long is that? 1, 2, 3, 4, 5. I've got another pentane. And I've got another, that space is bugging me. And I've got another 2 methyl branches, so it's another dimethyl pentane. I like these examples that I gave. There's a reason for it. I've got a dimethyl pentane. This was a dimethyl one too, but it was in the 2 and 3. And you can see that these ones, it's just shifted these positions. So 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. So I can either have 2 dimethyl pentane or 4 dimethyl pentane. Well, I need to go to the lowest number, so it's 2, 2 dimethyl pentane. Okay, so I need to put these numbers in because I could have, if I say dimethyl pentane, you can come back at me and go, do you mean 2,3 dimethyl pentane or 2,2 dimethyl pentane? Because they're both different molecules. Slightly different. Definitely different. Alright, let's look at example 6 here. Have we got carbon-to-carbon single bonds? Yep, I've got an ane. Okay. If you're observant already, you might have seen something. Look at this. This screams out to me. I've got a cycle. Okay. So I've got a cycle that is the longest chain. I've got a cycle in there, and it is 1, 2, 3, 4 carbons long. Methylbutane. So I've got a butane, and I've got a cyclobutane. Okay, cyclobutane. It's not accounting for these 2 branches off here. There's 2 methyl branches. It's a dimethyl cyclobutane. Okay. Now, with cyclic, where you put the number, it doesn't, there's no kind of starting position, but you want to get the lowest number. So what we want to do is put a 1 on any of these. It's symmetrical, it doesn't matter. And because we want the lowest numbers, I'm not going to go this way and then this 2. No, that's not going to give me the lowest number, because then I'm going to get 1, 4. I want to go and make this one the 2, and this one the 3, and this one the 4. So I've got 1, 2 dimethyl cyclobutane. And I need to put those numbers in. I can't just say dimethyl cyclobutane, because you could also have 1, 3 dimethyl cyclobutane. Okay? So if you tell me dimethyl cyclobutane, I'm going to come back at you and say, do you mean 1, 2 dimethyl cyclobutane? Or do you mean 1, 3 dimethyl cyclobutane? It can't be 1, 4, because that's just the same molecule as 1, 2. Just turn it around a bit. Okay, name this one. Okay, it's an alkane. Well, it's telling us from the question, but let's just make sure. Single, 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 single. Okay, oh, single. Got a lot of branches here. But I can see this long chain here. Alright, so I've got an N. How many's in this long chain? 1, 2, 3, 4, 5, 6, 6. Oh, I could have also gone, this is another branchy one where I could have gone this way, or this way, or this way at the end, but let's just keep it as simple as possible. Okay, lots of scribbles, sorry guys. I'll rub them out. Okay, so I've got an hexane. I'll draw a circle around that main branch. Please do this type of thing in your test too. It makes it easier. Here's my main branch, or what's hanging off it. It's easy to see what's hanging off it. Here we've got a methyl there, and a methyl there, and a methyl here. Okay, you can see that all these kind of things are hanging over this left-hand side of the molecule. So with a bit of knowledge, I'm going to say, well, I'm going to start the left-hand side as number 1, number 2, 3, 4, 5, 6. Okay, so I've got 3 methyls. So I've got a trimethyl hexane. Didn't leave myself enough space. Trimethyl hexane. Okay, and what position they're in? Well, there's 2 on the 2, and there's 1 on the 4. Okay, let's just make sure that if we 1, 2, 3, there's 1 on the 3 and 2 on the 5. No, I've numbered it the right way with 1 over this side. So it is 2, 2, 4 dash dimethylhexane. Hopefully the writing's a bit better than mine. Alright, couple more examples. Let's keep going. Okay. Here, I can see that I've got this chain here. 1, 2, 3, 4, 5, 6 carbons long. Okay, it must be a hexane. Hold on. Now this is a very, very good trick that the HSC loves to do. Don't presume that the straightest chain is the longest chain, and that's why I threw this example in. Oh, doesn't make any difference. Did I say that was a hexane? 1, 2, 3, 4, 5, 6. Well, whichever way you go, it's still 6. But the HSC does love to throw in a bendy alkane and try and trick people up so that the straightest part isn't the longest chain. But anyway, both of these are hexane. It doesn't matter which of that branch or that branch I do, so I'm going to keep it here. And I've got a methyl branch and I've got an ethyl branch. Okay, thinking about the numbers, it's not obvious because these branches are in the middle, so I'm going to try the different ways. 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6. Okay, so let's start to write it. I know I had a hexane, and it was, I've got a methyl and an ethyl, okay? The ethyl, E comes before M, so so working from the end, it's a methyl hexane. Okay, the methyl has to be on a number. I'm going to leave, that's just a dash, a placeholder for a number. I'm going to leave that, and I'm going to come back to it. And it's a ethyl there that comes before this dash, and there's a number here. So I've got a number, dash ethyl, dash number, dash methyl hexane. I need to decide on the numbering, okay? I want the smallest numbering. So I've got, if I go from 1 here, I've got a 3 ethyl, 5 methyl. Just write them here. Or if I go the other way, I've got a 2 methyl and 4. Okay? The lowest set of numbers of these two is the 2 and the 4. The 2 and the 4 are smaller than the 3 and the 5. So it's a 2 and a 4. So make sure that the numbers go in the correct position. The ethyl comes first and the ethyl's in the 4 position. Notice the smallest number doesn't come first. Oh, I'm on my eraser. So it's a 4 ethyl, 2 methyl hexane. Get rid of those. Get rid of those. Okay. Notice we're getting more difficult. Okay, have we got an alkane in this example? Straight, straight, straight. Oh, look at this cycle. Straight. Okay, we've got an aim. Okay, as I just said, I found a cycle in there. I'm going to circle that because that will take the priority as being the basis of the name. Excuse me. And I've got these 2 branches. So, I've got a cyclo-something-ane. Let's count the numbers. 1, 2, 3, 4, 5, 6. So I've got a cyclohexane. I don't like this space. Bugging me. Notice that we tend to name backwards. I don't listen backwards. So starting with aim, the number, and all that type of thing makes it so much easier. So I've got a cyclohexane. I did put numbers on them, but remember where you start the 1 in a cyclo is very arbitrary, and you'll want to start at a position to give you the smallest numbers for whatever's hanging off it. So what I'm going to do is start 1 here or 1 here. It doesn't really matter which one it is. Okay? But what I might do is, I know I've got an ethyl branch and I know I've got a methyl branch. So ethyl will come first. Okay. And I've got a methyl there. And I know I've got a methyl. So we've got a some number ethyl, some number methyl, cyclohexane. So it doesn't really matter so much if I put the 1 on the methyl or the 1 on the ethyl. Have a choice if the other rules aren't dictating it. Alright, that's the examples I'll go through. There's an example from the textbook. And next video, I'm going to come back and we're going to draw some alkanes. Or should I do it now? Oh, we've only got 2. Let's power through. Okay, drawing alkanes. Okay, if you're given the name of a molecule, you can use these steps to draw the structure. So it's like the reverse of what we've been doing. So we need to identify that it's an alkane. Does it end in ane? The number of carbons, any branches, and if there's anything else there. It's kind of like what we've been doing in reverse. So here our molecule in the first example is 2-methylpentane. So start backwards to ane. So it's going to be carbon-to-carbon single bonds, and there's pent. There's 5 of them. So I'm going to draw in my backbone. Carbon, single bond, carbon, 2, 3, 4, 5. Okay? I'm going to leave the hydrogens to last. What else is on there? There's a methyl branch in the 2 position. Make it easier for yourself. Doesn't matter where you put the one on either end, but start left to right because you're drawing this molecule. You'll say. So there's a methyl branch on the two. So there's my carbon. I've got nothing else there, so now I go through to put the hydrogens on there. Okay, just bear with me. I put all these hydrogens on. And look at the picture. Oh, it's a bit tedious. It's a bit boring. Okay, this one's fully expanded. I could do a condensed form. Okay, so what I'm going to do is erase that. Oh, look at this. Okay, I'm going to do a condensed formula. I'm going to start the same. 1, 2, 3, 4, 5. And a methyl in the 2 position. Okay, I haven't got anything else. What I can do is, that's an N1 plus CH3. That's an N1 plus CH3. That carbon has 3 bonds, so it must only have 1 bond to a hydrogen. This one's a CH2 because it's in the middle of the chain, CH2, CH3. And now I've got my condensed structure. Okay, let's push it a bit further. I know we're just beginning, we'll get there eventually. I'll do a nice skeletal structure. Okay. Remember the carbon ring in the end is just drawing the carbon-to-carbon link. So 1, 2, 3, 4, 5. There's my container back. And on the second one in, I've got a methyl. So I've got 1 carbon-to-carbon bond there. So there's my skeletal structure of 2 methyl pentane. That's a lot quicker, isn't it? But you're just beginning. Practice those earlier structures. Practice your expanded. Practice your condensed. Okay, we've got another example. 2,2,3 trimethylpentane. Okay. Carbon, 3, 4, 5. I've identified that it's an ane and there's 5 in there. Okay, I've got 3 methyl branches on the 2 and the 2 and the 3. Make it easier. Start with your 1, 2, 3, 4, 5. And I've got a carbon there, a carbon coming off 2, and a carbon coming off 3. Doesn't matter which side of the 3 I put it on, the molecule will twist. It's a single bond. They rotate. Okay, all the rest are hydrogens. Okay, I'm going to do condensed. That's an N1CH3. That's an N1CH3. That's an N1CH3. This one in the middle here, it's got 4 bonds. There's no hydrogens there. This one here has got 3 bonds, so it's a CH. And this one's an N, so it's a CH3. This one's along a chain, so it's a CH2. And this one's on the N, so it's a CH3. Okay, so there's my condensed one. Let's do a skeletal one, because it's fun. I've got my pentane backbone. So 1 carbon. Oh, why does it do that zoomy thing? Zoom back out. 1 carbon, 2, 3, 4, 5. There's my carbon backbone. Okay, don't worry about the hydrogens in the skeletal. I have got 2 methyls on the 2. 1, 2. And I've got a methyl on the 3. 3. And that's my molecule. That's not very straight. That's a bit better. Skeletal structures save time, but a little bit harder to comprehend. Okay, you got enough to do, check your understanding. And next video, I'll go on about alkenes. Thanks for listening.